Thanks, Elizabeth, and thanks for all our guests. I'm excited to be here today with some good folks from Amazon and, of course, Tensing, who I think has been with us on all our Any AI series, and also with a good customer at Amberside. Yeah, so today we're gonna go over FME and Amazon Bedrock, and of course, as always, we're going to cover a real story showing how people are using it today. Yeah.
And we're very pleased to be joined by an array of guest speakers today. Very excited to go through presenter introductions here. Firstly, I'll hand things over to Chris to introduce himself.
Awesome. Thanks, Elizabeth. Hey, my name's Chris. I lead our customer solutions team here at Safe Software, and I've been a part of almost every AI webinar, so I figured I'd keep the trend going. Our team focuses on making sure our customers are getting the most value out of their FME deployment. So that's a little bit of a reason why I'm here. Don, I'll hand it over to you.
Yeah, and I'm Don Murray, the CEO, and you could say I've been here since the dawn of Safe Software, and I work on the vision and get to work with incredible people at Safe and also partners. So with that, I'll pass it off to Eric.
Hello, everyone. My name is Eric Cornwell. I'm a Senior Spatial Computing Solution Architect at Amazon Web Services. And today we'll be diving into kind of the 3D aspect. And as a builder, I'll uncover some of those aspects, but nice to meet everybody.
And hi, everyone. I'm Satya. I'm a solutions architect here at Amazon Web Services too. I'm the dedicated account SA for Safe Software. And in this session, I'm going to primarily cover about Amazon Bedrock and have all the features that are available for you to play around with. So.
Hello, everyone. I'm Simon Green, and I'm Principal Technical Specialist at Avineon-Tensing, a partner of Safe Software.
And my name's Jamie. I'm Chief of Staff at Amberside Energy, and Simon here from Tensing has helped put together some really nice AI image recognition tools that we're going to demonstrate today.
All right, fantastic. Thank you so much, everyone. Just briefly here, if you are newer to our Livestorm platform for webinars, if you have any audio issues during the webinar, click that help button on the bottom left. It has 4 simple steps to take. If you'd like to share your emoji reactions with us during the webinar, we love to see those. You can use that react button on the bottom middle. And if you do have any questions at all during the webinar, please, we encourage you to drop those into the questions tab. We will be keeping an eye on that throughout and potentially getting to some during the webinar. And then also we'll have a live Q&A segment at the end with our speakers. All right, and lastly, if you are just joining us now, please let us know where you're tuning in from in the chat. We love to see that as well. And our peak of data and AI, Dawn, it's coming to Seattle, Washington in just a month away now.
Yeah, super exciting. And it's in the Seattle area, and we're really looking forward to it. So if you're interested, reach out. It's going to be a lot of fun. And you can view this as kind of a precursor to what you're going to see in Seattle. We have lots of surprise and amazing things we're going to unveil as well. So we're super excited, and it's hard not to talk about it. Yeah.
Awesome. Yeah, and if you have yet to check out the agenda, take a look. It was released a couple of weeks ago now.
Yeah, so thanks, Elizabeth. And so the agenda, quick introduction for those who don't know what FME is. I'm going to be super high level because I don't want to turn this into all about FME. And then we're going to dive right into why everybody tuned in, learn a bit about Amazon Bedrock, what it can do, and talk about some AI and 3D pipelines that Amazon and us are working with. And then, of course, always a case study, always a real success story so people can see how this can make a difference in the real world. And again, we're excited to be here with Tensing and their customer, Amberside. And then we'll talk a bit about some new transformers that we keep adding to FME. In this case, of course, transformers focused on Bedrock. And then we'll wrap it up.
Excellent. All right. At this point, I will get our presenters to turn off their webcams just so we can save on some bandwidth for the remainder here. And I'll pass things back over to Dawn for our introduction.
Yeah, so here we go. Today, we're going to show you a number of things. We're going to show how you can leverage Bedrock with FME. And so an overview of Amazon Bedrock, and then with an example. And then, of course, we're going to dive into Amberside Energy, who's really going to show how it's made a difference to them and their customers. And in this case, it's going to be around planning and managing solar installation. And yeah, so you're going to see how FME and Bedrock, when it comes to imagery, addresses some of the following things. Before AI, you would manually tag images, and that would be very time consuming and error prone. And you're going to see just how easy it is now with FME and Bedrock. Integrating different AI models into systems is complex. And of course, what AI do you want to use depends on what you're doing. And that really makes it difficult. Of course, bringing AI, if there's one thing that we can say about AI, it loves data. If one thing we can say about data is it loves AI. So of course, how do you bring all your data to AI so you can maximize your insights? And then scaling your AI solutions. Of course, that's what Amazon does best, is scale. And then of course, you want to automate it. As data continues to arrive, you want to process the data right away. So automation is key to everything. And so today we're going to show the entire platform. FME is the only all data any AI platform, and you'll see Form, you'll see Flow, and Form is the authoring environment. You can think of it like the no-code IDE, and FME Flow is where all these things run. They engage all the different services, automation, and just bring the whole thing to life. And then FME Flow Hosted is our SaaS version of FME Flow that runs on the Amazon platform. And yeah, data, when it comes to data, if you have data, we can support it. We're continually adding more support for different data. I'm just scanning that slide looking for one that's missing. Oh yeah, graph. So we also do graph databases. We're constantly adding new. So yeah, and really we've stopped counting the number of different data sources and things that we support. So there we go. Yeah. And with that, I'm going to hand it off to Eric and Satya at Amazon.
Thank you, Don. That was a great introduction. So now I'm going to go over Amazon Bedrock and some of the features that are available for you through FME that you can try out. Generative AI customers primarily come to us asking three questions. Which model to use, which is appropriate for their use cases? How can they move quickly? And how can they keep their data secure and private in these applications? So to answer all of these, Amazon has come up with a service called Amazon Bedrock that would allow you to access industry-leading foundation models through a single API. It's optimized for cost, latency, and accuracy. It allows you to customize your models based on your own data, and it provides you some of the industry-leading safety and responsible AI checks. And finally, it gives you a tool that would allow you to build agent orchestrations that would in turn help you execute some of the complex tasks. Amazon Bedrock allows you to access a broad choice of models from various third-party providers such as AI21 Labs, Anthropic, Cohere, DeepSeek, etc. We at Amazon strongly believe that no single model will rule them all. That's one of the reasons why we are trying to provide all the foundation models. Could it be any modality like text, images, audio, video, etc. And we ourselves released some of the industry-leading foundation models called Nova. We have various types of models from text/image to text generation. We have Amazon Nova Micro, which offers you lower cost and latency, to Amazon Lite, Nova Pro, and Nova Premium. And in different modalities, we also provide Amazon Nova Canvas for image generation and Nova Reel for video generations. From the Anthropic side, we have some of the industry-leading foundation models such as Claude 3.7, which gives you extended thinking/reasoning capability that allows you to give better responses. And we also have Claude 3.5 Sonnet or 3 Haiku for more cost-optimized and traditional foundation model. And we recently released DeepSeek R1 Nav, which is fully managed on AWS. This would let you access its reasoning capabilities through a single API, and it comes with a security and monitoring pre-configured, and it also gives you cost control features that would make sure you're sticking to your constraints. So on Amazon Bedrock, we have various inference consumption models. If you're prototyping with these foundation models to build your generative AI application, you can go with on-demand, where you just pay as you go and there is no commitment. And then if you want to build that POC into production, that's when you would want to go with provision throughput, which guarantees an X amount of throughput. And finally, we have batch inference. If you have really large data sets, which you want to run through these models. Now, from the broader set of tools that are available on Amazon Bedrock, it allows you to customize your foundation models in different formats. So there are 4 primary ways that you can customize these foundation models with your data. The first one is prompt engineering, where you tweak your query going in to let the foundation model give a better answer out. And then we have retrieval augmented generation, where you package your question with the relevant context such that the large language model do not deviate or hallucinate in the responses. And then we have fine-tuning and continued pre-training, which are slightly more computationally expensive, but would give you a better performance in some of the downstream tasks, such as mathematical reasoning or any sort of orchestrations that you want to build. From the retrieval augmented generation, where you would want to package your questions with the relevant context to get better answers out, we have Amazon Bedrock knowledge bases, which streamlines the whole implementation of this. All you have to do is choose what database that you want to integrate knowledge bases with, and the large language model that you want to use it against. And the best thing about this is this orchestration is free of cost. You only pay for the underlying foundation models and the vector database that you would be using. Now, from the fine-tuning and continued pre-training, we have pre-configured jobs that where you can just upload the dataset that you want to train your large language model against. And Amazon Bedrock will take care of all of the underlying infrastructure provisioning and running the necessary scripts to get your large language model towards your data. And upon that, it will give you some artifacts out, which you can directly deploy on AWS with the provision throughput inference option. And that would let you use those customized models in production. Finally, security is a huge component when you're building generative AI applications. So Amazon Bedrock came out with guardrails, which allows you to configure certain thresholds to filter any sort of undesired or potentially harmful text or images that could be coming in or going out of the large language models that you're using. It also gives you some tools, such as removing personally identified information. Could it be going into the model or out of the model, so that you can be rest assured that none of the customer data is being leaked or being lost anywhere. And finally, it filters any sort of hallucinations and detects by detecting the groundedness and the relevance to the responses that it's supposed to be giving, so that you can also make sure by applying guardrails on your applications, you could mitigate any sort of hallucinations that would give wrong answers or could use the model's internal knowledge to answer some of the answers that should be relevant to the context that you're providing. Amazon takes security very seriously, and it's our zero job here. We have trickled down it into Amazon Bedrock as well. So none of the customer data is used to train the underlying models. Could it be Amazon's models or the third-party providers? And all of the data is encrypted in Rust and at transit. And if you want even higher amount of security so that none of the pipelines could access the data, you can also set up connections to your VPC where you store your data so that it passes through your configured pipelines. And then data remains in the region where the API is. So if you have any compliance requirements, which requires your data to be in the region that you're using it in. And finally, I just want to give a special mention to its Amazon Bedrock agents. This is a feature which lets you take various questions that are coming from your users into different components and execute that against certain actions. So you can use this large language model to execute various complex tasks, which might require multi-step reasoning and access to various data sources or company systems. So let's say if you want to trigger an action that needs to be verified by a user. In those situations, you can just ask the Bedrock agents that you've configured with the necessary tools and the data sources in the background. You can just ask the Bedrock agent to go ahead and do that action for you, and it will actually go ahead and call the relevant APIs or the data sources to get you the right answer, and would ask you whether that answer actually answers your question or not. So it's a great way to simplify a lot of complex tasks or complex systems that you're building right now. With that, there are some barcodes that you can scan to get started on Amazon Bedrock. And there are some step-by-step tutorials and hands-on workshops too to give you more relevant implementation details. With that, I'll hand it over to Eric to talk more about AI and 3D pipelines on FME and AWS.
Thank you, Satya. Yeah, I'd like to shift gears and start to talk about the intersection of AI and 3D and what that looks like as a pipeline using FME and AWS. Generally, customers come to us and they have their data, right? And they want to view and analyze the data. And then most importantly, they want to take action on that data. And with FME by Safe Software and AWS allows you to automate that workflow, that pipeline within a no-code interface, and all through scaling using the cloud. And when we talk about the AI ML model, Satya brought up a good point, is that this could be any model on Bedrock. Bedrock allows us to even bring our own model, which we can then host on Bedrock. And that's most important when we talk about 3D, is that we don't have a lot of 3D foundation models out there, right? And they're mostly in open source. And what Amazon allows us to do, AWS, is to host that open source model on Bedrock. And then we can then start to make predictions on your data set. So when we talk about 3D content, it can mean a lot of things and a lot of different use cases. I generally like to group them into 3 different categories. We have e-commerce on the left, where we have a augmented reality view in your room. And so this allows the customer to make a more informed decision whether to purchase the product or not. And again, going back to the previous slide, is the user wants to use the data to make a more informed decision. The same is true all across industry. Even with drone imagery, you can think of a cell phone tower with a lot of installations that are happening, and you want to keep track of those installations in a 3D format. And so what you're able to do is take images using a drone, circling the cell phone tower, and you can convert those images into 3D. And that's kind of on the cutting edge of AI currently. And then last but not least, we have digital twins. And this is usually in the construction space, where you have as built versus as designed. Maybe you have sensors out in the field monitoring the building process, and you can then monitor when you're going out of spec, when you're deviating from the plan. That way you can make corrective actions sooner. Now, the challenges with 3D really come into play with these 3 different categories. And the reason why we don't see 3D everywhere is because it's a manual process to create this 3D content. And it typically requires this specialized software and a lot of manual work. Now with FME by Safe Software, they have this no-code interface, which allows us to kind of jump over that hurdle, and we're able to, build these 3D experiences a lot easier. Secondly is consuming these resources locally. A lot of customers come to us with these 3D workloads that they're running locally, which doesn't scale, right? And that's really why AWS comes into this picture, is that we're able to scale the pipeline, scale it up, scale it down when we're not using it. And then last but not least is owning the pipeline. We have a lot of customers that start in open source. They refine the open source package, make it their own, make it proprietary. And with FME Safe Software, the customer still owns the pipeline. They can run it, and they can have the flexibility of both owning the pipeline and running it at scale. And that's kind of the point that I wanted to drive home, is that you can run these pipelines in a demo environment locally, but then the next is to scale this, right? And that's really what we're talking about, is scaling these 3D applications. Now, use case. I wanted to hone in on a few use cases here, but it all starts with the input image. You can think of a city worker that has an iPad and a camera with them, so they're able to take images of equipment. They're able to process those images through AI ML. Maybe it's an inspection report. Maybe they're trying to detect corrosion. And so with that, the whole pipeline could get kicked off with the image, and then we can automate an inspection report at the end. That's one use case. Another use case could be, maybe I want to build a digital twin of this real life object. That way I can catalog the 3D object. So I can take images, multiple images, while walking around the equipment. I can upload those images into the 3D pipeline, and then we can output a 3D object, super realistic, that we can then see digitally and then inspect, and kind of have this 3D digital twin to then make a more informed decision, right? It's all about the data, and then processing the data, and then performing some action on that data. I hope you all found this very informative. This is kind of like the cutting edge on what AWS and Safe Software is working on, are these 3D pipelines. And these are just a few use cases that we've been working on. Thank you.
Yeah, so thank you, Eric, and thank you, Satya. That was really great. And with that, I'm going to pass it over to Simon from our great partnership with Tensing, who's jumped on AI right from the beginning, and Jamie from Amberside, who's going to share his exciting use case story on how they use AWS Bedrock.
Great. Well, thanks, Don, for the introduction. So I'll give you a little bit of background about Amberside Energy first. So Amberside Energy was founded in 2016, and we originally were a grid consultancy business spotting capacity in the UK. And from there, we developed a number of renewable energy tools, which are listed on the slide in front of you. The main one being a grid capacity estimation tool. And then what the guys from Tensing have helped us work on today is an image recognition tool that we use in our asset management business. So asset management is a range of services that we use for technical clients, including site surveys and technical reports. So what we're going to show you today is one of our new tools that we've developed for site survey analysis. Solar site surveys are very detailed. They can involve a number of photographs and drone surveys, and typically a site survey, whilst it might last an hour, could contain up to 300 photos. So typically we do 2 inspections per year. The 2 inspections are one in the summer when we're generating and one in winter when there's no generation, because you can spot different faults in different situations. We also get monthly reports from O&M contractors. So what that means is that overall we can end up with nearly 1,000 photos per site per year. Now, we've got 20 large sites as a business. So imagine we've got nearly 20,000 images coming in each year, which are a lot of data to look at, and what we look for varies by photo as well. If you imagine we have all these images, how do we tag them? How do we know what they contain? There's one main method of doing this, which is what the O&M contractors do, which is to compile them in folders. So you can see that typically in the industry, there's 9 types of image we can see on a site survey, and then there's the classic extra for anything interesting you see as well. Now, what makes this difficult is A, there's so many photos, and B, how much time it takes to put these photos away. So even manually reviewing them, you're probably looking at about 15 seconds per photograph. So you can see we've got 15 seconds to look at per photograph, 20,000 images to look at each year. You can work out quite quickly how much time and effort this could take. So if we multiply the 2 numbers together, you'll see that we could be looking at over 2 weeks of manual work of just clicking and dragging photos to folders. And again, if we take a low estimation of cost, you can see quite quickly how that can stack up. So there's a clear need. It doesn't seem like a need on the surface, but there's a clear need and benefit from this tool if we can automatically, with a degree of confidence, file photographs away in the correct folder. So on the next slide, you'll see a typical challenge we have. This is a photograph we've taken of a site in the UK, and you can see what it is on the right-hand side. It's some solar panels in the field, but you'll notice on the post, there's a CCTV camera. Now, most of us would put it in the solar panel box, which would be folder 3. However, there is a risk or a concern that you could put it under grounds or security. So what we need to do is put it in the most important folder, not necessarily any folder. So if we fast forward to what Simon and the guys from Tensing have done, they've created a tool that will automatically do this for us. It will put the photo in the correct folder with minimal effort. And Simon's going to run through how this was developed.
Excellent. Thank you, Jamie. So this is just a very high-level overview of the process and technique that we are doing for Amberside. FME Flow sits at the heart of this, and it's an automation that is doing most of the work for us. So the photos are uploaded to a Dropbox folder, a zipped folder of photos, all uncategorized, get uploaded to Dropbox. And because of FME Flow's automation trigger, of modified Dropbox folder, FME can pick that up and trigger the running of a workspace to then profile and process those images. So you can see there that in the big square in the middle, this is essentially the content of the workspace at a very high level. So FME will extract the image and base64 encode it, which will then get passed to a AI. So in this case, it's Anthropic Claude Sonnet 3. That will get classified for each image. And then once we know the classification of the image, we can assign it a folder, and then that image gets copied to the correct folder in Dropbox. When it's finished processing all the images, then an email with a summary report is sent to the user. And if there's any issues with the workspace, success or failure, then they get notified by a Teams message, again triggered through the automation in FME Flow. So let's deep dive a little bit into the workspace. So we'll have a little demo of what's going on. Okay, so this is the workspace. I'm going to click run and go on and process the photos that we've got. So there's a zip file basically. This is essentially just running locally on FME Form, just to give you an idea of the process that's involved here. So the zip file would replicate the zip file that gets uploaded to Dropbox. FME Flow would trigger the running of this workspace to give me the source of that zip file. FME then extracts that zip file to get all of the images and copies them locally to a temporary folder on FME Flow. And then from there, we can start reading those images in automatically. So for us to be able to upload these images to the Anthropic Claude 3 Sonnet AI, we need to be able to extract and test some properties around that each individual image. So we use the raster property extractor to do this, and then test for essentially the maximum size of an image that the AI can handle, and then resample it if it exceeds that threshold, so that we can then get that image processed and uploaded. We remove any excess attributes, and then from there we extract the image as a binary and then base 64 encode it. So we're not physically passing the file from my local file system up to the AI service through the API. We're creating a blob binary object and passing that data as base 64 encoded through to the API. Okay, so this is all pre-prep work that we need to do in FME before we send it off to the AI. So you'll notice that when we clicked play on this and ran the automation, we were able to set some parameters. So we just need to expose those parameters here, create attributes out of them so that we can essentially pass the required API fields through the Python caller. But just to deep dive a little bit into the prompting, which I think is probably one of the most important parts of the process. So this is basically setting the scene for the image when it gets uploaded to AI to be able to understand what needs to be done by that service. So we create a JSON file, which essentially gives it guidance. And as Jamie mentioned, we've got 7 or 8 different categories of folder that each image could potentially fall into. So what we want to do is give the AI some instruction. So we've created a number of different key value pairs here for containing information on what we want it not to include, i.e. images that might contain internal security systems. We don't want that to be placed into grounds flora and fauna. We've got some interesting image descriptions here that can be used to essentially coerce the image to be recognized and then categorized by what might appear in there. So if there's an infrared camera view or a security guard on patrol, that will help categorize it into the security system folder or perimeter and security folder. Some tailored keywords. So if any items that might appear in the image are identified as keywords, that can all help in the categorization of that image. So we've got a number of different categories, as I mentioned, so we can have a look at all of those here. So each category is unique, and through a little bit of trial and error, but also through the understanding of the photographs that Jamie and his team were able to provide, we're able to come up with this prompt that can help categorize our images for us. So there's the 8 categories there. And then right at the end, we are very explicit in the way that we say only return JSON. So when the API has created and generated its output, we want that to be structured in JSON consistently. So in order to do that, we define what our output schema looks like. So what we want is a folder name and also a justification. So why do you classify this image as you have? And that justification can then act as a bit of a post-process check to make sure that we're happy with what has been decided. And essentially, we give it some instructions. So use the guidance as a tool to categorize the images and make use of all of the different keywords inside of that JSON and come to a decision. So the prompting is really an important part of this whole process, really. And the fact that we've created a JSON prompt just enables us to have more control over what we would like from the output of Claude model. So that's a prompt. We then send it through the Python caller. Just a quick note actually here. So this workflow that we're running through here was developed before SAFE updated the Amazon Bedrock connector to version 3, which fixes a lot of these kind of string replacement issues and automatically handles and outputs the JSON without having to do all this string manipulation. So that's really rather handy. So this workspace will get updated with that in the future. So once we have that response from the API, we need to extract our information from it. So inside of the JSON extractor, we are extracting what the AI has determined to be the folder name here. So you can see that we've got that as perimeter and security. And then the next one as inverters and their HV, low V systems, and then the justification. Okay, so we'll look at some of these images afterwards and we can decide whether the correct category and file folder system is assigned. So we can use that JSON now, that extracted attributes, to then create the necessary folders to be created inside of Dropbox. So we tidy up some attributes, remove attributes that we're not interested in anymore, and then send that onto the Dropbox connector where we upload the image that's sourced in that temporary folder, and we specify the upload path there, which we've created inside the attribute manager. And then just to finish, just for completeness, we generate a report that then gets sent to the user in the form of an email with a summary of the number of photos that were processed and the number of photos that were determined to be in each folder. And that's just an HTML report, which is sent via email. So if we take a look at Dropbox folder, we can have a look at the folders and some of the images where those were categorized into. Okay, so this is the folder structure inside of Dropbox. So we saw that there was one folder called inverters and their HV low voltage systems. We can click on there and see the image or images that got uploaded to there. So we can see that we've got some infrastructure there that would be representative of inverters and high voltage, low voltage system. And if we go back to here, maybe I think there's grounds, flora and fauna. And again, click on this image here, and we can see that we've got a field with a little bit of a solar panel in the corner there, but very much a focus on grounds, flora and fauna. So out of those images, the 5 images, they've all got categorized. So we've got this one as well. So this is a security gate, which is fairly synonymous with perimeter and security. So that concludes the demonstration. I'll hand that back to Jamie now to finish up.
Thanks, Simon. So you can see there how quickly that was to do and how much time that saves us as a company. So if we look forward to what we're doing next as a business, we've got 3 tools that we are looking to market this year. One of them is a governance and diligence tool where you can overview your project performance. Again, you can imagine importing photos for your site visits in there, quickly located in the right areas, in the right folders too. We've got a grid capacity system, which is still our bread and butter. And then finally, as we discussed just now, we've got an asset management service where we are using this tool to improve our performance. So with that all said, you can see how useful these tools are and how we hope to increase productivity at Amberside. And thank you for Simon for demonstrating clearly how it works.
Okay, thank you, Jamie. So just to finish up then, we are running an FME AI and All AI training course in the beginning of May and also the beginning of July. We've got a half day each day of that course, running 1st, 2nd of May, 2nd and 3rd of July. So if there's things inside of this webinar that have piqued your interest, you want to learn a little bit more, then we will be talking all things AI and doing training within that, creating AI-driven workflows with FME.
And if you want to hear anything else about what we're using at Amberside, please do get in touch. And I'd strongly recommend Tensing for putting together workflows in FME. Thank you.
Thank you, Jamie. And likewise, if anybody has any questions about the process, some of the technology that we use there, then I'm more than happy to take some questions.
Yeah, thank you so much, Simon and Jamie. That's really good. Just great. And I do encourage listeners out there to reach out to Simon or sign up for those courses. Tensing is our partner that has embraced the AI more than any other. And so we've done many webinars with Tensing because they're the first ones we go to now. Yeah, and thank you so much, Jamie, from Amberside, and just to show yet another way that AI can increase productivity and efficiency and allow you to do things that otherwise would be very difficult. And with that, now I want to pass it over to Chris Berger and show us some other amazing stuff.
Awesome. Thank you, Jamie and Simon. That was a great example of leveraging AWS Bedrock in a real world example. For this next section, I'm going to focus on the updates to the Amazon Bedrock connector that were recently published to the FME Hub. So previously we were on version 2, which only had a couple of parameters in the authentication in addition to a few parameters in the general section, which we have recently expanded on and released in version 3, which is now available on the FME Hub. This includes a few updates to both security and functionality, and just to highlight them here on the screen, you'll see that there is now an AWS session token that is required, in addition to the new models that are available from the Amazon Bedrock Marketplace, including Nova, Llama, and Claude 3. We've also split out the prompt into both a user and a system prompt, and this is helping to ensure your model is enabled and initialized to the instructions that you require. One of the key updates here, as I've pointed out in all of our other AI connectors, and it is no different on the Amazon Bedrock side, is the support for structured outputs. This is a checkbox option for that parameter to enable it or disable it. By default, it is off, though I would highly recommend using this and supplying the JSON that you wish to receive your response back as. Again, it makes your data integration workflows with AI very predictable and easy to use downstream, as you can flatten and or fragment as needed in your workspace in order to make the attributes usable instead of simply just generating text in every output. So I would highly recommend reviewing the documentation for structured outputs. And if you haven't already seen the previous 2 AI webinars, we do touch on structured outputs in quite good detail in both of those. Lastly, we added the advanced section, which adds some additional parameters here for things like temperature. Feel free to explore those and tweak as needed. So I'm going to walk us through an example of chaining Amazon Bedrock connectors together. And the goal of this would be to obviously access the latest models and use structured outputs in addition to the advanced parameters. So what I'm going to be doing here is showing you how you can chain multiple Amazon Bedrock connectors together by accessing the best of breed model for each step in the data integration workflow. You don't have to use one single model for the entire process. You can use multiple or even different services if you would wish. So this is something that we would highly recommend. Make sure you're looking for the best of breed model for your specific task in that workflow. The key of this, of course, is we're going to chain multiple Amazon Bedrock connectors together in that single workspace, and the result will enable a reliable low-code generative AI workflow, which has actionable outputs thanks to the structured outputs that we added support for. So let's take a look at this in action. To start us off, this is the scenario that we're going to be looking at. We are receiving multiple JSON files with slightly different schemas, and we want to perform some change detection and ensure these are mapped into a structured output on the other end. As shown in the previous two webinars, I really enjoy using these structured outputs for schema management and handling multiple files that may have differing schemas. And this is no different when it comes to the structure of a JSON or XML-based file. Here specifically, we're looking at a couple of men's NCAA basketball teams, including their rosters, coaches, the team, and city. Figured it was fitting given March Madness is currently on the go. What we're going to be doing here is taking these two files and converting them into a single output schema so that we can use these downstream in our operation. How you would approach this in a traditional setting would be by leveraging something called change detection. And this is where you would break out the JSON either into individual attributes, or if you have an array, array or a list rather, you'd explode the list and then make sure all of those schema elements are accessible in the canvas so you can perform change detection on them. In this case, since we're working with those JSON files, I actually want to keep them intact and just let an AI service do the work for me. So I'll collapse that bookmark down. We're not going to be working on that. Here, what we're going to be doing in that first step is filling out the parameters as needed to connect to Amazon Bedrock, and we are going to leverage Amazon's Nova Pro model here because it is really good at working with structured outputs. So my instructions for this model are that it is simply a specialist in reformatting JSON objects or JSON files into the structured output as defined in my user prompt. So in my user prompt, I'm simply just feeding in the JSON, and with my structured output, which is a portion of the user prompt, I will ask it to come back with a specific schema for the city, conference, head coach, years with the team, and that's going to be an array as the head coach items, in addition to the roster as an array as well. We're doing this intentionally because we're going to be creating some SQL statements, which we can then use to perform insert statements, or if we needed to join into a Snowflake table, or specifically creating the Snowflake insert statements because we're going to leverage the variant data type. So I'll go ahead and run this to the very end here, just so we can see what's going on. And as it's happening, I'll talk you through the next step in here. The second portion of the Amazon Bedrock connector is also going to be using Amazon Nova Pro. And this is going to be just identifying which teams are located where. So effectively, we're going to find out which city, state, and the actual coordinates are for each arena. Since I have the structured outputs enabled on both, you may have noticed that I have a JSON flattener and a JSON fragmenter. Again, this makes it very predictable. I don't have to do specific parsing of the generative text. I know exactly what the schema is coming back, so I can expose those elements and then use them downstream in my operation. So that's exactly what we're doing in that JSON flattener. We're then creating the vertex. So this is just applying the information that we applied from that model and creating geometry for it with the lat long 84. So this will allow us to feed it into our third model here, which is Meta's Llama 3.21b model. The reason we're using this specific model for this task is because it is excellent at generating code, including SQL. So what we're going to be doing is creating SQL delimited statements to insert these into a Snowflake database table. And this will allow us to ensure that the data is following the exact structure or schema as we have defined in Snowflake and have it written out as needed. And we can see from the last Amazon Bedrock connector, we have a response attribute. This first example does not have a list of players, unfortunately. So I'll go to the second one, which has our insert statement in the response attribute. And we can see, if I zoom in just a little bit here, we now have an insert statement for our schema and table, in addition to all the fields that we need to insert into. So we have the player's name or the roster, which we're going to be writing into, the team name, and so on and so forth. Everything here is formatted exactly as it needs to go into Snowflake. So that is fantastic. Of course, from here, you can build out the rest of your workflow, whether you wanted to use the SQL creator or the SQL executor rather, or you wanted to use the Snowflake writer directly. That is totally optional. Just wanted to demonstrate that, of course, these models are capable of creating code. So if you want to create SQL code, you can do so in your workspace. What I'm going to demonstrate next is actually another key portion of this. So since Amazon's Bedrock is a model marketplace enabled platform, you have the ability to add new models. So you'll notice in these parameters here, this is a fixed list of models to choose from. As this list changes, we may not be able to keep up with this. What you can do is right click on the transform itself, click embed. In this case, I just want to embed this one specific instance, but you can embed all in the workspace. And what this will allow you to do is edit the custom transformer. So it'll open it up in a new tab. Here you can actually see the contents of this custom transformer, and this will show you all the intricacies of extracting the parameters that you've been requested and how it all filters out and gets ready for the Python caller, which is actually the bridge between FME and the Amazon Bedrock system. Opening up the Python caller, you can see here this is the Amazon Nova one. We have one Python caller per service that they're working with. The reason for this is the data that is required, or the parameters for arguments for this, are all slightly different depending on the model that you're accessing. So we've broken it up by the major services because we've noticed the pattern for Amazon services always look the same, Claude always looks the same, and Llama is the same thing. They all are kind of grouped together and follow the same schemas within their own services. So you can follow along in these few examples, and likely what it would require is just a few simple changes, which you can copy and paste from a single Python caller and make the changes as needed. Of course, definitely review the documentation on the Amazon Bedrock service itself. So this just goes through and shows you what's actually happening. The actual integration is this Bedrock runtime Boto 3 client portion, and then here's the code that actually inserts the system and user prompt in addition to any additional components like structured output and so on and so forth. So that covers a demo of all the updates with the v3 Python endpoints for the Amazon Bedrock connector and how to actually edit them. Again, if you have a need to add support for new models in here, we will do our best to keep this list updated, but if it beats us and gets ahead of us in terms of capabilities, you can always have the ability to embed this and edit it in your workspace itself and add additional functionality or add model endpoints that you are needing. If you are going to be venturing into this and you have interest in other models that you might want to deploy, perhaps from other services, you can definitely review the Python and FME Basics tutorial. That will walk you through all of the specifics on how to get started with Python and the Python caller itself. And the last great resource that I will mention here is the Amazon Bedrock Boto 3 examples. This just goes to show you how to actually get started with the Python API from the Amazon perspective. And with that, we'll head into the conclusion of the webinar.
Well, thanks for that, Chris. That was great, showing us what we can do with FME and Bedrock through the transformers on the hubs. Thanks for that. Now, into the conclusion, we saw a lot today. Just a few things. If you don't know about Safe Software, we've been around for over 30 years and 25,000 different organizations around the world use us. We're quite a large and growing company, 128 countries and 200,000 users around the world. And now a quick summary. We covered a lot, so it's hard to know what to highlight, but I've highlighted a few things here. First of all, in the middle there, you can see what the FME pipelines look like. This is from the Amberside workflow. And then you can also see during the Amazon presentation, Eric also covered that. And FME is the pipeline used to bring data to the various AIs that have been used in this presentation. And of course, it's all about automation, being able to ingest data as it arrives, large amounts of data. In the top right there, you can see Amazon Bedrock and the broad choice of models they have today. And it's interesting, over time, they're adding more. So some of the new ones you can see there, DeepSeek, obviously, and then Poolside is coming. And over time, I'm sure they're going to add more. So even Amazon is embracing the spirit of any AI, because all these different AIs have different strengths. By using FME to connect to Bedrock, you get everything that Bedrock also supports. So that's great. And then just some of the things from the Amberside. They use the imagery that they were collecting to look at the perimeter and security, the grounds, the flora and fauna. Where do they need to maintain that so that the solar panels are able to produce as much energy as possible? And you can see in the bottom left there, you can just see the number of images that they're going to process, 1,000 photos per site per year. And currently they have 20 large sites. And of course, over time, they're going to add more. So you can just see the value that FME and AI bring to being able to analyze those 20,000 images per year in an automatic way. Yeah, so we covered a lot. And Elizabeth is now going to tell us about all the resources.
Excellent. Thanks, Dawn. Yeah, so just to take us through some resources to help you get started, we're all about free resources here at SAFE. Our FME Academy is home to free instructor-led training. So we encourage you to take a look over there on our Academy page. And I'll also highlight our webinars. We have lots of upcoming over at safe.com/webinars. And then we also have on-demand webinars. So you can filter and search depending on what topic you are looking to learn more about. Follow us on social to see more on AI and FME. We have a lot of really good information over on our LinkedIn and Instagram pages regarding AI, a lot more content that you can learn from there. Dawn, I'm not sure if you wanted to say anything else on this one about our socials.
Yeah, absolutely. We encourage you to follow on LinkedIn or Instagram. Lots going on in the world of FME. You'll get some insights into what's coming to the peak and hear about some really great success stories from other partners around the world that haven't been highlighted today.
Awesome. All right, in terms of next steps, if you are newer to the FME platform, I'd encourage you to take a look at our accelerator course. It's 90 minutes free of charge, no downloads required or anything. Very helpful and effective way to learn the basics of FME. And we'd also love to help you get started. So get in touch with us, info@safe.com, to chat about anything data. We'd be happy to have a talk with you. All right, and if you are a member of our FME community, just a badge code as a thank you for joining us here today. I'll drop that code in the chat if you do redeem those. And if you have yet to take a look at our community, it is a great place to network with other users alike and experts, and lots of forum opportunities there. Someone might be wondering the exact same question that you have and it might already be answered. So a great place to network and gain solutions there. Once again, our peak of data and AI is coming to Seattle, Washington this May 6th to 8th. We hope to see you there. And we do have some time remaining here for questions. So I'll invite our presenters on stage and we can take a look over them together. Awesome. We got a lot of great questions. So thank you so much, everyone, for dropping those in as we went along here.
Yeah, thank you. That was, that was really great. There was one question I'll just pull out right away, and this one's from Peter. Just if I want to take the FME AI course, Simon, what do I need to have an FME installed? What do I need to, to do?
Yeah, good question. So it's going to be provided on Strigo, so we don't need any prerequisites on that. I think as long as you've touched FME and you sort of know your way around it, that's fine. I think I mentioned that you don't need to be an advanced user here, but some FME experience would be useful. We'll be dipping into things like basic API calls and things like that to start with, and then ramping things up to start communicating with the AI using HTTP callers as well as the custom transformers and stuff available on the hub.
Great. And the other thing, are we able to share all the some of the workspaces and the prompts? Because what really is it really takes some mystery out of this whole thing when people see that everything you do with all the data becomes down to prompt engineering, and prompt engineering is a real thing, right? And so, and that is really sort of, otherwise, if you didn't know, you'd just watch this, you go, holy smokes, how does it do that? And it's because it's just these prompts that. And I know when I started out using ChatGPT, my prompts were like, 10 words. I almost used like a smart Google search. And now literally sometimes I write paragraphs and paragraphs and then send it in, right? And so, so that would be great. And that was a great question from, Nick Ranikar about, hey, can we see the prompts, right? I tried to paste it in the chat, but it exceeded the character limit, so in the old days, in the early days, your 10 words would have fit, so there you go.
That's right.
And then there was a question about accuracy, I think. from Lewis, when does the process fails? How do we know, how confident the AI was with the classification and things, and things like that? Because those are always great. One thing I really liked about Amberside was how he categorized all the images and put them into buckets, right? And then of course you can imagine that is like, that really is an AI agent. If all of a sudden it sends an email or does something and sends it out to a person who's going to take action, or maybe it itself takes action and sounds an alarm or things like that, right? And, so that ability to be watching images as they come by. And I would argue with them that I think I just wouldn't want to be the person who has 15 seconds to classify every image. I think he was underestimating the task. The guy didn't even get lunch, as far as I could tell, or the girl didn't even get lunch. Anyway, so yeah. So I guess go back to the the confidence. How does AI tell us this, or how does it tell us that confidence?
Yeah. So I mean, as Jamie pointed out, it can be a little bit subjective, and what I might classify as something is different to maybe what you might. And AI is kind of no different in that sense sometimes. So the key for us was to get it to report back why it thinks it, and if there's something strange in that, then that can allow us to go and dig a bit deeper, and see whether it needs to be moved to a different folder. The other thing also is the sort of the summary at the end that gets sent via email. That will give you a breakdown of the number of photos that have been moved into particular folders. And a site survey, the person that's taken those photos will know roughly how many photos they've taken of certain bits of infrastructure and stuff like that. So if there's more photos than would be expected in a particular folder, it would give you a prompt to go and have a look.
Yeah, awesome. And there was a good question from Horatio too around 3D recognition of models, and that's some of the things we're talking to Eric about, generating 3D models automatically of things. So anything you want to say on that, Eric?
Yeah, I mean, it really comes down to what metadata you're holding within the 3D object, right? And customers have various ways to store that data. If the data is available, use LLM to pipe it in and solve the problem for you, right? That's really where customers are going. But yeah, hopefully that answered some of the questions. But spatial LLM is really coming to life this year. And as well as 3D diffusion models, they're getting way better. So be on the lookout.
Yeah. And that's a great kind of hint for the peak. We have something really exciting coming out around the whole spatial and LLMs, and I'm trying not to use another word after spatial because I'll give it all away. But anyway, yeah. So yeah, anything you saw, Chris, that you wanted to highlight?
I'm just taking one last look through the chat here. It looks like, someone has mentioned that the use case that Simon, you presented, would be a really good fit in the telecom industry. So that'd be great to see, again, just another use case for how people can repurpose the inspiration from webinars like this in their own industry. So I don't think there were any other questions that we have missed here. Everything else looks good.
Thanks, Chris. And the user stories are everything, right? Like it just brings it to life. Otherwise, we're just vendors talking about possible things, and so that's why we always get a real use case that just makes it real. And of course, here we were looking at solar panels, but they could be images of anything. They could be farmland, they could be forests, they could be growth of cities, they could be floods, they could be absolutely anything. And the workflows that Simon and Amberside have built, with Bedrock, is just they can classify any imagery, right? And so, and so the other thing we're talking about it safe is that it's important to remember that generative AI is your assistant. There's not an authority, right? So you always have to have somebody running it or overseeing it who actually understands the domain. So. But as far as a turbocharger for an authority, if you can just get so much more done, right? Like there's nobody who would have that skill who wants to spend their life is 15 seconds classifying every image, right? So yeah, but you set it up. Now that person can go and do other amazing stuff, right? Yeah. So anyway, good. And I just want to thank our guests, right? Like Eric and Satya. Thank you so much. Really super exciting, and look forward to continuing to work with you both. And Simon, yeah, I can't wait to meet you in person in Seattle. And thanks, Jamie from Amberside, and of course, Chris and Elizabeth. You both are just amazing, and I'm lucky to be able to work with you. So, with that, I think
Likewise.
yeah. So thank you so much, everybody. Have a great day.
Awesome.
Yeah,
Thanks everyone. Take care.
Okay.
Yep. Bye.
Bye for now.